Hello students, we are learning the lesson sound. Today we are going to discuss about high and low pitch of sound. So one activity is given here on page number 123. In this activity we need a wooden board of 80 to 90 centimeter long and 5 centimeter wide. We are going to hammer two nails into it, each a few centimeters away from its two ends. The figure is shown in 18.4 how to hammer the nails at the two ends of the wooden board. Then we are going to tie a thin metal wire to the ends of the nails so that the wire is stretched tightly between them. So to the two nails we are going to tie a metal wire like a guitar or like a violin. Insert a wedge-shaped wooden or plastic block under the wire near each of the nails and plug the wire lightly. So we have wound the metal wire tightly to the nails, and then we are going to insert wedge-shaped wooden or plastic block. Wedge shape means we are going to give tension to the मेटल वायर. टेन्शन मीन्स ताण वाढवण्यासाठी आपण त्यांच्यामध्ये ट्रँग्युलर शेपचे वेजेस ॲड करणार आहोत. अँड प्लग द वायर लाईटली. सो लाईक अ गिटार और लाईक अ व्हायोलिन यू हॅव टू प्लग द वायर युझिंग युअर फिंगर्स दॅट आर शोन इन 18.4. सो did you hear any sound? Yes, you can able to hear light sound because we have used metal wire, and metals have the property of sonority. Sonority means metals make a beautiful sound. So observe whether the wire vibrates. The wire will vibrate and we are able to listen the sound. Now insert 2 or 3 small rectangular blocks below the wedge shaped block on one side in such a way that the length of the wire does not change. So we are going to increase the height from one side, that is shown in 18.4, figure number 18.4. We are going to add some rectangular shaped blocks, means we are going to increase the tension in the metal wire. And keep in mind that the length of the wire does not change, means the wire gets stretched but the length is constant. Observe whether there is any change in the tension in the wire. So you will know that if we increase the height from one side, the tension in wire gets increased. Now plug the wire with your finger and listen to the sound. Also watch its vibration. So when there is increased tension in the wire, we will hear different types of sound, and we see that the wire vibrates fast because frequency gets increased. Note the difference you perceive in its frequency. What can you infer from this? When tension in the wire is increased, the frequency is seen to increase. So when we stretch the wire, the frequency increases, and when we reduce the tension, frequency decreases. So we also perceive a difference in the sound generated, because sound is related with the frequency. So when frequency increases, sound is different. When frequency is decreased, sound is different. When the tension is increased, the resulting sound is shriller, and when the tension is reduced, the sound is also less shrill. This is what is called the high and low pitch of sound. Means music players, the players that musicians play violin, guitar, adjust the tension in their wires of the instrument like guitar or violin to get proper pitch of sound. Suppose they want low pitch, they lose the wire, and if they want higher pitch, they tight the wires, because there are screws fitted in violin or guitar which are called as string instruments. So two questions are asked here. Which of the sounds, the roar of a lion or the hum of a mosquito, has the higher pitch? So the roar of a lion will have higher pitch, and humming of a mosquito will have lower pitch. So using this information example, you will be able to find out what is meant by pitch of sound. Second question is there, what structures in the sitar help to produce higher and lower pitch sounds? In sitar there are screw fitted, and when we lose the screw, the tension in wire gets decreased, so you will get low pitch, and if you tight the screw, means the tension in wire increases and you will get higher pitch. So intensity of sound and sound level. Loudness or softness of sound is indicated by two terms, namely intensity of sound and sound level. So you know that if there is loud sound, we call it that the sound level is higher or the intensity of sound is higher. But when someone speaks softly, we say that sound level is lowered or the intensity of sound is lowered. Sound level is the intensity of sound as perceived by our ears. So suppose there is a big speaker of DJ and you will hear the sound, we keep hands on our ears because the sound is having higher intensity as well as the level of sound is higher. The intensity of sound is proportional to the square of the amplitude of vibration. For example, if the amplitude is doubled, the intensity of sound becomes 4 times as much. So when the amplitude is higher, we get intensity increase, and it is in the proportion of square of the amplitude of vibration. So amplitude is known to you. Amplitude is the maximum distance from the middle point. So one important information we are going to get that sound level is measured in decibel. The unit of sound level is decibel and it is denoted by small d and capital B. So it was named decibel in honor of the work of the scientist Alexander Graham Bell. So you know about Graham Bell, which invented the telephone. So Graham Bell invented about how to measure sound level. So on his honor, the unit of sound level is given as decibel. Means Graham Bell is the inventor. The magnitude of sound level decibels can be deduced from the intensity of the sound using a mathematical formula. So we are able to calculate the sound level in decibel by calculating the intensity of sound using a mathematical formula. When intensity of sound becomes 10 times the original, the sound level increases by 10 decibel. So intensity and level of sound are having similar meaning. Means when the intensity of sound is higher, the sound level also higher. So when intensity of sound becomes 10 times the original sound, sound level also increase by 10 decibel. Means sound level and intensity of sound are having somewhat similar meaning. Do you know decibel levels of some common sounds? That is, beginning of audible sound is 0 decibel. Normal breathing is having sound level 10 decibel. Murmuring from 5 meters away is sound of 30 decibel. Normal conversation between two persons is having sound level up to 60 decibel. Heavy traffic have sound 70 decibel. Ordinary factories has sound level 80 decibel. Jet engine creates sound of 130 decibel. Start of ear splitting sound means we have to keep our hands on our ears. That sound starts from 120 decibel. Hearing is temporarily affected by sounds of frequency greater than 1000 Hz and levels higher than 100 decibel. So the sound that is having frequency greater than 100 Hz or higher than 10 decibel, we have to keep our hands on ears because this sound affect our ear. हे या तीव्रतेचे आवाज आपल्याला त्रासदायक वाटतात आणि म्हणून आपण कानांवर चक्क हात ठेवतो किंवा कानांमध्ये बोटं घालून ते आवाज आपल्या कानात येऊ नये याचा आपण प्रयत्न करतो. सो हिअरिंग दिस काइंड ऑफ साऊंड्स कॅन रिझल्ट इन टेम्पररी डीफनेस. सो फॉर सम टाईम वी फील डीफनेस. काही वेळासाठी आपल्या कानांमध्ये बहिरेपणा निर्माण होऊ शकतो जर 1,000 हर्ट्ज किंवा 100 डेसिबलपेक्षा जास्त इंटेन्सिटीचा साऊंड आपल्या कानांवर पडला तर. वर्कर्स हू वर्क नियर एरोप्लेन इंजिन्स एक्सपिरियन्स दिस. सो द वर्कर्स दॅट आर हिअरिंग these sounds all the day will have the same problem of temporary deafness. So after discussing about sound level, pitch of sound, intensity, we are going to get information about audible and inaudible sounds. So use your brain power that is given on page number 124. What would be the difference perceived between hearing only two people in the class talking to each other and all the children talking to one another at the same time? So when two people are talking with each other, the sound will be audible, means we can able to hear the sound. But when all the class of 40 to 50 students talking at the same time, we have to keep our hands on the ears because this sound is quite affecting our ears, or it is give nuisance to the person. So we are going to get new concept, that is audible sound. Audible sound means the frequency of the sound audible to human beings is between 20 hertz to 20,000 hertz. So the sound between 20 hertz to 20,000 hertz is called as audible sound. माणसाची ध्वनी ऐकण्याची क्षमता 20 हर्ट्जपासून 20,000 हर्ट्जपर्यंत आहे. याच्यामधील या दरम्यानचे आवाज आपण ऐकू शकतो. 20 हर्ट्जपेक्षा कमी आणि 20,000 हर्ट्जपेक्षा जास्त फ्रिक्वेन्सीचे साऊंड मानवी कानांना ऐकू येऊ शकत नाहीत. वी कॅन ओनली हिअर साऊंड्स इन दिस फ्रिक्वेन्सी रेंज फ्रॉम 20 हर्ट्ज टू 20,000 हर्ट्ज. So from 20 to 20,000 hertz, it is called as audible sound. And new concepts, infrasonic sound and ultrasonic sound. Have you ever heard the sound of the movement of our hands or of the movement of leaves falling from a tree? So if we wave our hand in air, means when we makes bye-bye to someone, we cannot hear the sound of our hands. Movement is there, vibrations are there, but we cannot hear the sound. When a leaf fall from the tree, we cannot hear the sound. So these sounds that we cannot hear means the frequency is less than 20 hertz. It is called as infrasonic sound. So another activity is given here. Try this. Take an oscillator and swing an oscillator which makes 3 to 4 oscillations in a second, and listen carefully for any sound it makes. So when the oscillator makes 3 to 4 oscillations in 1 second, means the frequency is 3 to 4 hertz. So humans cannot hear sounds of frequency less than 20 hertz. Oscillator मध्ये आपण एका सेकंदात 3 to 4 ऑसिलेशन्स होतील अशा पद्धतीने ऑसिलेटरला मोशन दिली तर 3 to 4 ऑसिलेशन्स 1 सेकंडमध्ये, म्हणजेच त्या ऑसिलेटरची फ्रिक्वेन्सी 3 to 4 हर्ट्ज असेल तर आपल्याला मूवमेंट डोळ्याने दिसेल, परंतु आपल्याला त्याचा साऊंड ऐकू येत नाही, कारण मानवी कानाची क्षमता 20 हर्ट्ज आणि त्याच्या पुढील साऊंड ऐकण्याची आहे. 20 हर्ट्जपेक्षा कमी फ्रिक्वेन्सीचे साऊंड मानवी कानांना ऐकू येऊ शकत नाहीत. सो अ साऊंड विथ अ फ्रिक्वेन्सी लेस दॅन 20 हर्ट्ज आर कॉल्ड ॲज इन्फ्रासॉनिक साऊंड. अँड these infrasonic sounds are created or produced by some animals like whale, blue whale or elephants, rhinoceros. These animals make infrasonic sounds to communicate with each other. Blue whale, elephant, rhinoceros यासारखे प्राणी इन्फ्रासॉनिक साऊंड्स क्रिएट करतात आणि त्या माध्यमातून ते एकमेकांशी संवाद साधतात. पण हे इन्फ्रासॉनिक साऊंड्स मानवी कानांना ऐकू येऊ शकत नाहीत. So after discussing about infrasonic sounds, we are going to discuss about ultrasonic sound. So ultrasonic sounds means the sounds that are greater than 20,000 hertz. A sound with a frequency higher than 20,000 hertz is called ultrasonic sound. So human cannot able to hear these sounds because human ear can hear sound between 20 hertz to 20,000. So higher than 20,000 are not able to hear using human ear. So some animals like dog can hear these ultrasonic sounds. One activity is given here for you. Find out there is evidence that elephants communicate with each other over distances of up to 10 km using infrasonic sound inaudible to us. It is also believed that dogs and other animals can perceive ultrasonic sound signals in advance of an impending earthquake. Find out more about this from the internet. So interesting information is there. बघा आपण पाहिलं की एलिफंट हे इन्फ्रासॉनिक साऊंड तयार करतात आपल्या एकमेकांशी कम्युनिकेशन करण्यासाठी. तर असे काही पुरावे सापडलेले आहेत की एक एलिफंट त्याच्यापासून 10 किलोमीटर दूर असलेल्या एलिफंटशी इन्फ्रासॉनिक साऊंड्सद्वारे कम्युनिकेट करू शकतो. हे इन्फ्रासॉनिक साऊंड मानवी कानांना ऐकू येत नाहीत. त्याचबरोबर डॉग्ससारखे जे ॲनिमल्स आहेत हे ॲनिमल्स अल्ट्रासॉनिक साऊंड म्हणजे 20,000 हर्ट्जपेक्षा हायर फ्रिक्वेन्सीचे साऊंड ऐकू शकतात. आणि म्हणूनच डॉग्स वगैरे सारखे प्राणी बघा झोपताना ते कान जमिनीला टेकवून झोपलेले असतात आणि त्यामुळे जमिनीच्या भूपृष्ठावर येणारे अर्थक्वेकसारखं संकट हे या डॉग्सना सगळ्यात आधी कळतं कारण त्यांना अल्ट्रासॉनिक साऊंड अर्थक्वेकमुळे क्रिएट होणारे अल्ट्रासॉनिक साऊंड ऐकू येऊ शकतात. हे अल्ट्रासॉनिक साऊंड्स 20,000 हर्ट्जपेक्षा जास्त फ्रिक्वेन्सीचे असल्यामुळे मानवी कानांना ऐकू येऊ शकत नाहीत. म्हणजेच कुत्र्यासारख्या प्राण्याला अर्थक्वेकची पूर्वसूचना मिळू शकते. सो दिस अल्ट्रासॉनिक साऊंड्स आर important in different industries as well as in the health sector also. So uses of ultrasonic sound. 7 uses are given here. To clean delicate ornaments and the tiny parts of a watch. Watch have delicate parts and that will be cleaned using ultrasonic sounds. And ornaments, delicate ornaments like gold or diamond jewelry is there. We can able to clean them using ultrasonic sound. Then to observe internal organs of the body. So ultrasonic sound is used in sonography treatment. Sonography is useful to observe internal organs. Third, to detect tumors in the brain. So we have know that in the medical field there are different machines available like CT scan, ultrasound sonography. In these techniques ultrasonic sounds are used to detect faults in a metal. So in metal impurity or metal defects can be known using ultrasonic sound. And in radar systems are used in our army, navy or air force, and these radar systems carried out using ultrasonic sounds then to kill certain microbes and insects. And last one is sonar, that is sound navigation and ranging, is used to locate a seabed or the position of a ship. So to get information about the seabed, समुद्राच्या तळभागाचा अंदाज घेण्यासाठी कारण समुद्राच्या तळालाच पेट्रोलियमचे साठे आहेत ते फाइंड आउट करण्यासाठी सोनार सिस्टीम ही शिपमध्ये इन्स्टॉल केलेली असते ज्याच्याबद्दलची अधिक माहिती आपल्याला स्टँडर्ड 8मध्ये मिळणार आहे. सो ॲट लास्ट वी आर गोइंग टू रीड दॅट फ्रिक्वेन्सी ऑफ साऊंड इज मेजर्ड इन हर्ट्स अँड ऑडिबल साऊंड फॉर ह्युमन बींग्स इज बिटवीन 20 हर्ट्स टू 20,000 हर्ट्स. Infrasonic sounds can be made by blue whale and ultrasonic sounds are made by dolphin and bat. Bat that it gets its food at night using the ultrasonic sound. Bat म्हणजे वटवाघूळ, डॉल्फिन हे प्राणी अल्ट्रासॉनिक साऊंड बाहेर टाकू शकतात आणि या अल्ट्रासॉनिक साऊंडच्या मदतीनेच बॅट म्हणजे वटवाघूळ रात्रीच्या वेळेला या अल्ट्रासॉनिक साऊंड्स क्रिएट करतं. त्याचे कान अत्यंत तीक्ष्ण असतात आणि ह्या तीक्ष्ण कानांमुळे त्याच्या शरीरातून त्याच्या तोंडाद्वारे बाहेर टाकलेले अल्ट्रासॉनिक साऊंड जेव्हा समोरच्या एखाद्या अडथळ्याकडे भक्ष्याला आपटतात आणि रिव्हर्स परत येतात, त्याची संवेदना कानांमुळे ह्या बॅटला समजते, ह्या वटवाघळाला समजते आणि रात्रीच्या वेळेला तो आपलं भक्ष्य पकडू शकतो किंवा समोर असलेल्या अडथळ्यापासून आपला बचाव करू शकतो. सो द pitch of sound is directly related to the frequency of sound. From the graph alongside, we get further information about the frequency of sound and infrasonic, audible and ultrasonic sound. So from 20 to 20,000 hertz, audible sounds are there. Less than 20 or higher than 20,000 are inaudible to human beings, and less than 20 are called as infrasonic, and greater than 20,000 are called as ultrasonic sounds.